Welcome to The Explainer. Today, we're digging into the hidden foundation of pretty much every computer you've ever used. A blueprint that's over half a century old, but it's still secretly powering every new gadget that comes out. So let's just start with what we all know. It feels like every single year there's a new phone, a faster laptop, a smarter, well, everything. Technology seems to be in this constant state of revolution. But is it really?
I mean, seriously, think about it. In just a handful of years, we went from carrying around these clunky laptops to having devices in our pockets that are just ridiculously powerful. That's a huge leap in size, speed, and what these things can do.
And it's not just our phones and laptops. These computer systems are absolutely everywhere now. They're embedded in our cars, our coffee makers, you name it. Our entire world is basically built on them.
But here's the big question, the one we're really going to dive into. What if all these amazing changes, all this new tech, is really just different clothes on the same old skeleton? What if underneath that shiny new surface, things have been surprisingly consistent? To get what's going on, we have to pull back the curtain and talk about something called computer architecture. Think of it as the fundamental design, the core blueprint that powers nearly every single computer you've ever laid hands on.
And here is the big twist, right? Despite all the changes we can see on the outside, the core ideas, the architecture itself, have been incredibly stable for over half a century. The newest supercomputer and the computer that flew us to the moon, yeah, they share a common ancestor.
So what is this unchanging blueprint? Well, it's really an architecture that's built on 4 timeless pillars. You are going to find them in every single system, from a tiny smartwatch to a massive data center. And they all work together to define what a computer even is. So let's actually break down these 4 essential pillars, because once you see them, you're going to start recognizing them everywhere.
First up, we have data. This is the raw material. It's the words in your email, the photo you just snapped, the song you're streaming. But to the computer, no matter what it is, it all gets boiled down to numbers, just waiting to be processed. Next, you've got the hardware. This is the physical stuff you can actually touch. We're talking about the CPU, the brain, the RAM, which is its short-term memory, the screen, the keyboard. This is the actual machinery that does the heavy lifting.
When we have software, this is kind of like the ghost in the machine. It's the set of instructions, your operating system, your apps, your code, that tells the hardware what to do with all that data. Without software, hardware is just a really expensive paperweight.
And finally, communication. This is the pillar that connects everything in our modern world. It's your Wi-Fi, it's Bluetooth, it's the internet. It's what allows all these different systems to talk to each other and share information.
Now, there is one single, absolutely genius idea that ties all of these pillars together and makes all of modern computing possible. It's something called the stored program concept. So before the 1950s, computers like the ENIAC were amazing, but they were also incredibly rigid. If you wanted to run a new program, you couldn't just click an icon. No, you had to physically get in there and start unplugging and replugging wires, a process that could take hours, sometimes even days. But then this brilliant mathematician, John von Neumann, comes along with this revolutionary idea. He basically said, hey, wait a minute. What if the instructions, the software, could be stored in the computer's memory right alongside the data? And that was it. That was the whole game changer. By treating programs just like any other piece of data, machines could suddenly switch tasks instantly just by loading different software. Every single time you open an app on your phone, you are using this concept from decades ago. It's kind of wild when you think about it.
Okay, so why does any of this matter, especially for you as a student who's getting ready for a career? I mean, why should you care about a 60-year-old idea?
Well, it matters because knowing this blueprint is like having a professional superpower. If you're going to be a programmer, it helps you write faster, more efficient code. If you're a systems analyst, you can design way better systems. Even if you're just a user, you'll make much smarter decisions about the tech you buy.
It gives you this ability to cut right through all the marketing hype and the confusing technical jargon. So when some company is trying to sell you on their new unified architecture or system on a chip, you'll actually understand the core concepts and know what really matters for performance.
Okay, let's wrap all this up with one final analogy that really brings it all home.
Look at these 2 devices. On the left, an old IBM mainframe. On the right, a sleek, modern tablet. The skin, what they look like, their size, their interface, is worlds apart, but their architectural skeleton, the CPU, the memory, the stored program concept, it's fundamentally the same.
And this right here is the real power of understanding the blueprint. This foundational knowledge, it doesn't get outdated. It is the key that lets you adapt and flow with technological change instead of constantly trying to catch up.
So the next time you see the next big thing in tech, I want you to look a little closer. Ask yourself, is this a true revolution, or is it a beautiful, modern new skin on a truly timeless 60-year-old idea?